This is part 1 of statistical analysis, in which we will focus on descriptive statistics and graphs. What are descriptive statistics? Descriptive statistics provide a summary of the data that we obtained from our sample. And by looking at descriptive statistics, we learn more about the population that the sample is thought to represent. Unlike inferential statistics, descriptive statistics are not based on probability theory, and thus cannot be used to draw final conclusions about differences between groups or about relationships between variables. Even so, descriptive statistics are useful to include when you present your statistical analysis. Typically, a table is provided with the overall sample size, the sample sizes of important subgroups, and with demographic or clinical characteristics, such as the average age, the number of subjects per sex, the means obtained on different variables, the standard deviations of those means, and so on. After you have obtained your data in numerical form, the first step is to enter your data in a spreadsheet, for example, in an MS Excel spreadsheet. Remember that if you have a pre-test, post-test design, or if you have more than one measuring point, you need to enter all your data in one data sheet. The next step would be to import your spreadsheet into your statistical software program, for example, into SPSS or Jamovi. It may be necessary to save your Excel file in a different format, depending on the program that you are using. The next thing that I like to do is to visually inspect my data by looking at normal distribution plots, histograms, scatter plots, box plots, and so on. Why does this help? Visual inspection of your data helps you to see what the spread of data points is in your sample. Looking at plots and graphs can also help you to identify variance in subgroups. It helps you to notice any trends, and it can help you to decide whether it is necessary to exclude outliers. When you become a bit more advanced, you can even use graphs to decide whether it is necessary to transform your data. A histogram, for example, which shows columns representing the number of occurrences of each value, could suggest a statistical distribution of concentration, and it also gives you an idea of the spread of your data. We will consider many different graphical representations of data in this course. However, to ensure that you understand the summary statistics that are shown on graphs, we want to first revise the concepts that underlie the various numerical descriptive statistics, such as mean, median, standard deviation, percentiles, and quartiles. This slide just contains a list of all the descriptive statistics that we are going to discuss. I'm not going to explain how to calculate a sample size, as I think that is self-explanatory. However, do note that when we talk about the overall sample size, we normally use a capital N. On the next slide, we will start with the central tendency. There are 3 descriptive statistics that tell us more about the central tendency in our data set, namely the mean, the median, and the mode. The mean equals the sum of all the values in the data set divided by the number of values in that data set. The median is the middle score of a data set, after the data set has been arranged from smallest value to largest value. In the data set below, the median is 45. The mode is the most frequent score in our data set. On a histogram, it represents the highest bar in the histogram. So in this little histogram on the right-hand side, the green bar is the mode. If you want to improve your understanding of the concepts that are related to central tendency even further, I strongly recommend that you visit this website. The next 2 concepts that we are going to discuss are percentiles and quartiles. Percentiles divide a data set into 100 equal parts. A percentile is simply a measure that tells us how many values in a data set was at or below a particular point. Consider this example. If a test taker scored at the 60th percentile, she scored the same or better than 60% of the other test takers. If a total of 500 students took the test, she scored at the same level or better than 300 students who took the test. 200 students scored better than she did. As the name suggests, quartiles break a data set into 4 equal parts. The first quartile is the 25th percentile. The second quartile is the 50th percentile. The third quartile is the 75th percentile. It's important to note that the median is both the 50th percentile and the second quartile. You always have to consider the dispersion in your dataset, as this will give you an idea of how the data points in your dataset are distributed. Dispersion, also known as variability, scatter, or spread, is the extent to which data points are stretched out or squeezed together. Common measures of statistical dispersion are the range, the standard deviation, and the interquartile range. Dispersion is contrasted with central tendency, and together they represent the most basic properties of the distribution in a dataset. We will go over the different measures of dispersion one by one. Let's first consider range. The range is the difference between the highest and lowest scores in a dataset and is the simplest measure of spread. The range is calculated by subtracting the minimum value from the maximum value. The second measure that we want to consider is the standard deviation. The standard deviation is a measure of the spread of scores around the mean. It is used in conjunction with the mean to summarize continuous data. Simply put, it tells us how much a data point deviates from the mean. Ideally, we want to know what the standard deviation is for a population, but in reality, we often only have data from a sample, so we can only estimate the sample standard deviation. For those of you who like mathematics, I've included the formula to calculate the standard deviation, and you are welcome to try it yourself. For those of you who do not like mathematics, don't worry, because your statistical software program will calculate the standard deviation for you. The third measure of dispersion that we will discuss is the interquartile range. The interquartile range is the difference between the third quartile and the first quartile. The interquartile range gives us an indication of the range of the middle half, in other words, the middle 50% of the scores in the distribution. As with central tendency, I've included a very useful website which you can visit should you want to further improve your understanding of the concept dispersion. The next statistic that we will consider is the normal distribution. A normal distribution is a symmetric distribution, where most of the data points cluster around the central tendency, and the probability of observing values further away from the mean or the central tendency is smaller in both directions. If your data is normally distributed, you will see a bell curve when you connect the bars on a histogram. Look at the example of a normal distribution that I included here. Let us assume that this histogram is a representation of math scores where the math test counted out of 150. As you can see, the majority of students that took the test obtained a raw score between 70 and 80. On both sides of this central tendency, the number of students that obtained a raw score lower than 70 or higher than 80 decreases. And as you move along the curve of the bell, you will see that very few students obtained a raw score that was very low, for example, between 10 and 20, or a raw score that was very high, between 130 and 140.